Hello everyone, my name is Sidney Balik and you're watching Balik Robotics. In today's video, we are going to learn what are the problems in the ReLU activation function and what are the uses of the other activation function like ELU, Leaky ReLU, Swish or etc. So without wasting much time, let's jump on the video. Okay, so first of all, we have studied ReLU activation function in the previous part. If you haven't seen the activation function part 1, then you should go and watch it first. Okay, so in ReLU activation function, what we do is like we make all negative value to 0. So this gives us a problem which we call dying ReLU problem. So what this does is like every neuron which is giving the negative value stay inactive, and that will stay inactive is like during the training it gives some value and the output is 0, and after that again in second epoch again it gives some value, my negative value, and then the result is 0. So it will be set to be the 0, and that will make the neuron dead, or it will never be activated. So weights will also be not updated. So this is the main problem why ReLU fails sometime. To solve this, we have multiple activation function which can solve the problem. First one is leaky ReLU. Leaky ReLU is also a part of a modified ReLU, or like just in this we add an alpha before the x if x is less than 0, and this alpha can be anything like 0.1 or 0.001, and then it will have a curve like this. Okay, so this is our ReLU, but as when we take alpha as 0.01x, then our curve is like this. So what is this? This is doing a this is giving a small negative output instead of 0. So here our weight will be not stuck, not without an updation, and this also solved the uh, ReLU dead problems. Okay, so this was about the leaky ReLU. In leaky ReLU, we just put some x and multiply by the sorry, we just put a random alpha and multiply by x. After that, there is another part which is parametric ReLU, PReLU. This is updation of leaky ReLU. Okay, in this we does not take 0.01 or any random value. Like we give a alpha I it update with the parameters and like bias and weights during the training. So um, in the is like ReLU, our curve goes like this. In leaky ReLU, our curve goes like this. In parametric ReLU, this curve can be changed because the value of alpha I will be changed during the training process. And after that, we have a ELU or exponentially linear unit. In this is our formula. Here we take alpha as like normally we take a 0 or 1. Like mainly we take it as a 1, and then it power to the x minus 1. So we use this equation. So what this give? This make our curve more smoother. It's like if you see that here the curve are just like here coming on 0, and then it start going up instantly. Here also there is no smoothness in the curve. So when we use exponential linear unit or ELU, then our curve is like a little bit more smooth. Okay, so there are some points that it smoothen the learning or it address dying neuron. Okay, all this I have already explained to you, and yeah, it help the convergence means it help reduce the loss function more faster. After that, Swish is a activation function which is created by Google Brain. So it is a self-gated. What it means, like formula is this, but it means that it selects that what thing is we should send to the training part, and which neuron values we do not need to send to the training part. So This provide a better performance than ReLU in many deep neural networks, and it's very efficient for models like CNN or other complex models like NLP or other things. So this is our ReLU graph, and this is a Swiss graph. Swiss graph is more smoother than ReLU, and its value is minus negative to negative. Sorry, minus infinity to infinity. Okay. GELU or Gaussian error linear unit. GELU is the best activation function for NLP model. It is used in BERT, GPT, and many other transformation architecture which you are currently using. So what it does, it just combine SGD and with non-linearity and give the result. It's like it also select like Swiss. It selected which element should be passed and which is should not be passed, and it give curve like this, more than smoother than this. So what are the like differentiation? Okay, in ReLU there is no smooth ReLU, Leaky ReLU, and Parametric ReLU. There is no smooth curve. But in Parametric ReLU there is the learnable parameter. That means it can adjust its value itself. Uh, in ReLU and Leaky ReLU there is just in Leaky ReLU is just we fix some part and give the alpha. Okay, and ELU, what else there is, like there is exponential form and it converts fast. In Swiss it is better in ReLU in many tasks like CNN and other things. And GELU is used in the uh, transformer models like SOTA or GPT or BERT or other things. So you just have to take the screenshots of this table and you will have a summary of this video. So this is graph wise, like ReLU graph goes from 0 to higher. In Leaky ReLU, a little below than 0. In Parametric ReLU, there is the multiple line or it can be adjusted during the training. LU is some more smoother. Swiss is more smoother than LU, and GELU is much smoother. Okay, so these are some activation function else than those which we have covered in the first one, and these solve our main problem, which is yeah. So it solve our problem, which is dying ReLU problem. So this is how we solve the dying ReLU problem, and what is dying ReLU problem is. I hope you like the video. Sorry because some murmuring in this video, and I will make that sure that this will not happen again in the next video. So thank you for your patience, and if you like this video, then please subscribe.